Dante Certification Program Level 3. In this module, we will go over topology and bandwidth. Topology refers to the way in which devices are connected in a network. In previous levels of Dante training, you were introduced to the concept of topology. In this module, we will see how topology impacts bandwidth. Right topology is crucial in preserving bandwidth. Therefore, it becomes essential that you understand how both topology and bandwidth interact with each other. In a previous module, we looked at how bandwidth is utilized in Dante. In this example, let's assume all 14 devices on the top switch are transmitting on a one-to-one mapping to the devices on the bottom switch. We know that we can't put all 1,344 megabits per second on a gigabit link. Why? Because the bandwidth has run out. One solution for this issue of bottleneck, as we've seen before, is using a 10 gigabit uplink between the two switches. Now, if that's not an option for you, luckily there are established methods for designing network topologies to help resolve such bottlenecks. If creating a 10 gigabit uplink between the two switches is not an option, we could design our network in such a way that we're not overwhelming those 1 gigabit uplinks. For example, we could put 7 devices on each edge switch and then link them to distribution switches on a core switch. When speaking of models, the first one we want to look at is the 3-layer hierarchical model. This model was first proposed by Cisco and divides enterprise networks into 3 layers: core, distribution, and access layer. The first layer in this model is the access layer. The access layer focuses on connecting client nodes such as workstations or Dante devices to the network via the edge switches. Second, we have the distribution layer. The distribution layer is the smart layer in the 3-layer model. Routing, filtering, and QoS policies are managed at the distribution layer. The third layer in this model is the core layer. The core network provides high-speed, high-redundant forwarding services to move packets between distribution layer devices in different regions of the network. Core switches and routers are usually the most powerful in terms of raw forwarding power in the enterprise. Core network devices manage the highest speed connections such as 10 gigabit Ethernet. As switch and router speeds have increased, collapsed core has become more normal. Like we mentioned previously, a 10 gigabit uplink is a completely valid solution to the bottleneck created in our example. In this model, the core layer acts as both the core and distribution layers from the classic model, which we saw earlier. The access layer still focuses on connecting client nodes to the network, but it's more likely to provide layer 3 switching services.